Hey guys, BuildZoid here, and welcome to the 9th weekly HWbot score roundup. Hopefully this time it'll be on time. As usual, in the past week, epic scores have been uploaded to HWbot, and we're going to be taking a look at quite a few of them that I thought were cool. So, yeah, let's get right into it, starting off with MLLR KLLR88's Cinebench R20 score for dual-core CPUs. I also know he goes by Miller, but I just find it fun to pronounce his nickname as MLLR KLLR. Because, like, it is fun to say. And if you don't think it's fun to say, you suck, I guess. Your life must be very boring. Anyway, yeah, dual-core Cinebench. So Core i3 7350K at 6.6 gigahertz, which is an insane frequency for these CPUs, because while they may be KB-like, they are not anywhere near the silicon quality of 7700Ks. Most 7350Ks need a hell of a lot more voltage to achieve the same clocks that 7700Ks do. And so 6.6 gigahertz in an all-core workload like this, that's also pretty long. Like, one of the, especially since it's a dual-core, right? Like, Cinebench takes longer the slower your CPU is. So running R20 on a 7350K at over 6.6 gigahertz is quite the achievement, and of course that is why Miller here has first place in the dual-core Cinebench R20 category. Also, what's kind of fun about the dual-core Cinebench R20 category is that the i3-7350K will probably be the king of this benchmark for a very, very long time. As we would need because the thing is, dual-core CPUs aren't really a thing anymore, right? And unlocked overclockable dual cores were not really a thing in general, right? Like the 7350K is a real anomaly as being a hyper-threaded, unlocked dual-core CPU. Its nearest predecessor would be the G3258, but that doesn't have hyper-threading. So, yeah, a kind of unique CPU that'll probably hold the top scores for dual-core benchmarks for a very long time. And anyway, Miller ran this 7350K on a ASRock Z170 MOC formula. One of the best, actually probably the best Z170 overclocking motherboard, as you know, it was basically the only one that wasn't ITX and came with came with a 1 DIMM per channel configuration. Has all of the different overclocking buttons. Also, Z170 was actually the time when motherboard vendors were first figuring out how to get the Kaby Lake and Kaby Lake and Skylake CPUs to run without cold bugs. So there's actually a lot of Z170 motherboards where you can't run full pot reliably. And the Z170 MOC formula is actually one of the first boards to sort of fix that. Well, I think the Asus boards had that fixed pretty early, but yeah, this was like one of the first boards where it's like you could actually boot at full pot, which actually with i3s is still pretty fiddly. They do often need quite specific voltage settings in order to function correctly, but yeah, so definitely this board really doesn't have much competition on the Z170 chipset. There's the nearest competition that I can think of for the socket in general would be the Z270 Apex, which of course is a different chipset. And the fun thing is the Z170 chipset actually has an advantage over Z270 in that you can actually overclock non-K CPUs on Z170. You can't do that on Z270 because Intel patched that because that was a bug. That wasn't supposed to work. So Intel eventually went to fix that for the Z270 boards. But yeah, Z170 MOC formula is probably one of the most flexible overclocking motherboards for Intel CPUs because of that. Because you've got the non-K overclocking mods available. You can run a 9900K on these. And of course, it's just a beast for Skylake and Kaby Lake CPU overclocking as well. So yeah, really, really cool board right there. Also a really cool LN2 This is a I don't know that it even has an official name, but this is like a super full pot optimized LN2 pot design. So by full pot I mean when you're running stuff on cold and it doesn't have a cold bug, and you can just run it as low a temperature as possible. That's referred to as full pot because you can just kind of fill up the LN2 pot with LN2, and it'll just be full of LN2 for like the duration, actually for the whole session. Like you can reboot with the LN2 pot full of LN2. And so this pot is really, really designed for that kind of sort of, I guess, operating condition where it's full of LN2 because it has a ton of surface area, and also it has like the whole center structure thing going on, which I suspect the reason this works really well is that actually with LN2, like imagine if you tried to apply LN2 directly to the die of a CPU. You'd immediately run into the problem of the LN2 boiling so quickly that it would actually start insulating the die from the still liquid nitrogen, so your cooling efficiency would kind of suck. But having some kind of like structure like this down the middle, which has quite a lot of copper, which is very thermally conductive, which incidentally gets more thermally conductive as it cools down, means that you actually have a lot of surface area for the LN2 to boil on. And, the heat is going to be traveling through that copper very, very quickly because, like, it's right at the like, this structure is right at the center of the LN2 pot, directly over the die. So, yeah, this is a really, really cool LN2 pot. I don't believe there's many of them out there. I think I've seen 3 different people use this. I'm not sure if that means that there's just 3 of them or if there's more of them, but yeah, quite a unique LN2 pot, and also apparently like really designed for full pot operation. And I think this one right here that Miller is using is probably even direct die, but I'm not sure. Yeah, it doesn't look like it's mentioned anywhere if it is running direct die here. And anyway, so yeah, really like just really cool combination of hardware right here between the LN2 pot and the motherboard, because the Z170 MOC formula is actually kind of rare, unfortunately, which is true for a lot of these sort of OC focused motherboards. They unfortunately aren't very popular with regular PC builders because apparently people really need 64 gigs of RAM or something. But anyway, in terms of the actual settings, so we've already, 6.6 over 6.6 gigahertz on the CPU, 4200, 14, 14, 14, 28 on the memory, and this isn't really pushing the limits of what Z170 can do in terms of memory settings, but the thing is, Cinebench R20 actually requires a pretty large amount of max mem in order to run at full speed. And also the i3-7350K, like I mentioned earlier, they're generally not comparable in silicon quality to 7700Ks in terms of the kind of core clocks you can run. The same applies to the memory controller. It generally doesn't clock memory as well as a 7700K will. And so this right here is kind of a combination of like, well, Cinebench doesn't care that much about memory. Cinebench R20 does require quite a significant amount of memory, which just limits how tight you can push the timings because you can't run as much voltage as you can when you have a really aggressive amount of max mem. Like on 2.5 gigs of RAM, you can run significantly better settings than you can on, say, I think Cinebench R20, you need like 4 gigs or 4.5 gigs of RAM for it to run properly. It slows down if you don't give it enough memory. So because of that, we're looking at pretty tame memory settings. In fact, really good DDR4 kits with like not i3-7350Ks would actually be able to do these settings at like almost daily volts. I think there's probably some unicorn grade memory sticks that like do that at 1.5 volts or 1.55. So yeah, but this is for competitive, this is for extreme overclocking, so we don't actually need to worry about, like, as long as you can do the settings within like 1.75 volts, you don't need to run max mem. And that's like the main criteria for getting Cinebench R20 to run properly. And then for Northbridge frequency, we're looking at 6.3 gigahertz, which is pretty normal for KB-like CPUs to run really, really high ring clocks because the ring is really small. Right, like compared to the more modern Intel CPUs where you have like 10 cores attached to the ring or 8 cores attached to the ring, with just 2 or 4 cores, you can run really, really quite high ring clocks. So yeah, really like great, like really cool score. probably going to be standing for a very long time because of well, if it's gonna fall to something, it's going to be another 7350K because there really aren't any other CPUs that get to compete in this ranking properly currently, and there probably won't be anytime in and there probably won't be any CPUs that will compete with the 7350K in the near future either. There is a chance that maybe like way in the future we'll have like a dual core which has so much IPC that even if it can't overclock and runs at like 3 gigahertz, it still beats a 7350K. But that is going to take a lot of IPC to do. So, yeah, congratulations to Miller on the i3 7350, like the top score in dual core Cinebench R20. And let's move on to the next score, which is Splav's GPU Pi for CPU 1 billion quad core category. Ryzen second place score with the Ryzen 3 5300G at 4.7 gigahertz, which might not immediately sound like a very high frequency until you look at the voltage that Splav is running. This is at almost 1.6 volts V-core. Now, apparently the chip was still somehow managing to stay at 75 degrees under load on AIO water cooling. This isn't sub-zero. Or like this isn't even on a chiller. But the thing is, I'm pretty sure this chip just like this, he's hit the limit of what the like scaling is for voltage. Because typically you can keep raising the voltage, but past a certain point, the frequency will either not go up or start going down as thermal effects from the extra voltage outweigh the benefits of the extra voltage in and of itself, right? Because like more voltage will generally give you more frequency, but if the internals of the chip get hot enough, eventually the operating temperature of the chip will actually basically lower your max frequency by more than the voltage is increasing it by. So there is a sort of ceiling to how far you can push the voltage before the frequency stops going up. Often happens not that long before you hit a point where the voltage starts causing causing permanent damage to the CPU. So Splav is absolutely hammering this poor 5300G. But this is almost certainly pre-testing for LN2, and I can't imagine it'll be long before we see Splav at the very top of the GPU Pi for CPU 1 billion quad-core rankings, as currently he's the second person to ever run a 5300G, and, you know, like, Yos is in first place at 5.5 gigahertz. I can't imagine that Splav won't be running that chip on LN2 very soon. And so we'll probably see him take first place pretty soon. Now, Splav is supported by ASRock. I wouldn't really call it I wouldn't really call it a sponsorship. It doesn't work like what you'd see in, I guess, like when you have sponsorships in other sports, they work quite differently from what you normally get in competitive overclocking, where it's mostly just hardware support. But anyway, he is running an ASRock X570 Aqua. For the motherboard, because he is supported by ASRock, and yeah, like the chip is absolutely flying for water cooling. Or there's not much information on 5300Gs, unfortunately, because they're not currently available at retail. AMD isn't planning to release these at retail, which is kind of unfortunate, because they are currently the fastest overclockable quad cores for a variety of benchmarks, but GPU Pi is one where they really shine. As you know, a 4.7 gigahertz 5300G is way faster than a 7 gigahertz 7740X, which is basically a fancy 7700K. So yeah, this score, like, it's pre-testing, so I'm assuming we're going to see something even better very, very soon. But yeah, for now, congratulations to Splav on his second place in GPU Pi for CPU 1 billion quad-core category score. And let's move on to the next score, which is ChipC's third place in Firestrike Extreme with 1 GPU using the RX 6900 XT, doing 2970 core and 2160 on the memory. ChipC's running an ASRock 6900 XT OC formula on water cooling. The CPU's on single-stage phase change at 5950X doing 5.2 gigahertz, and he beat my best Firestrike Extreme score by a couple hundred points. Yeah. Anyway, let's take a look at his like Firestrike, because Firestrike gives us a nice clock readout. So almost just under 3 gigahertz, right? On the water cooling there, and averaging around 2800 megahertz on the core, and then 2160 on the memory. I'm not sure, like so the annoying thing with the memory clock on the OC formula is like, so I've seen three different so ChipC runs 2160 on the memory. Tech Power Up, when they were overclocking the OC formula, they ended up at 2160. Splav's score is where actually didn't Splave have a Firestrike Extreme score? I'm pretty sure he did. And that was also a 2160. But anyway, so it kind of seems like the OC formula boards consistently do 2160. The thing is, you can't really compare them against the regular 6900 XTs, because the regular 6900 XTs aren't allowed to set their memory clock slider above 2150. So it's really hard to say if that's like a consistent benefit of the OC formula like PCB design, or if it's just kind of like 6900 XTs would do more memory frequency if AMD had allowed them to. Wait, oh, this is 3D Mark 11. Oh, there's Splave's score. Oops. Yeah, ChipC got 4th place in 3D Mark 11 as well. We'll get to that. Yeah, so this is the other one. Oh no, wait, this one's at 2140. Interesting. Interesting. So I'm misremembering that. But Tech Power Up, I'm pretty sure, was a 2160 on the memory. Anyway, card is, absolute. Wait, we're back on the 3D Mark 11 score. Oh, right, because when you close a tab, why would? Anyway, yeah. So card absolutely flying through 3D Mark Firestrike Extreme here. Running dual rank memory on a Crosshair 8 Hero motherboard, 3800, 14, 13, 13, 24. Incidentally, Firestrike Extreme's physics test on the 5950X, I'm not sure if this is universally true across other Ryzen chips, but with the 5950X, it starts being pretty memory bottlenecked in my experience. Like, memory settings make a big difference to the physics score, which is one of the main reasons I stopped using an X570 motherboard for it, because I just, like, none of the X570 boards I have can do high memory setting, none of them can match the B550 boards that I have for memory overclocking. So, yeah, anyway, congratulations to ChipC on the Firestrike Extreme score with the 6900, on the 3rd place in Firestrike Extreme. He also ran 3D Mark 11 performance. Now here, instead of the 5950X, the 6900 XT is being fed by the 11900K, because 3D Mark 11, it's a little bit old, and it can actually run the physics test all the way up to 32 CPU threads, but the problem is, because it's a little bit old, it also runs at insane frame rates. And insane frame rates require ridiculous amounts of single-threaded performance, and, a 5.6 gigahertz 11900K just does have more single-threaded performance than a 5950X. It also helps when you're running your memory at 3750, 1313, 24. So, so memory timing's optimized for memory latency. The CPU is on the single-stage phase change, and the GPU is doing 5 megahertz more core clock. I think we have a 3D Mark readout for frequencies here as oh, we don't. Okay, yeah, because it's an older test, so it doesn't do the clock monitoring. But yeah, so another solid score out of ChipC's 6900 XT, and you can see fans on absolutely everything. Actually, it looks kind of like he might have chilled water cooling on this. But yeah, so solid scores from ChipC there with the 6900 XT, and congratulations to him on those. And let's move on to the next score, which is MLLR KLLR Cinebench R20, but this time with, so first we had a 2-core CPU, very low core count. Now we've got a 3990X, 64 cores, very high core count. Running on liquid nitrogen, 4.84, I'll call it 4.85 gigahertz. Threadrippers are a nightmare to run. Your memory gets wet because the chip has the thermal transfer through the CPU when you're sitting idle to the motherboard and the rest of the system is just ridiculous because of the really high pin count. I think also the loading mechanism probably is relatively like thermal, also probably is helping out quite a bit with transferring the cold to the board as well. Yeah, so chip apps. Well, the thing is, I don't think it's really fair to say that this chip is really. Do these do? Yeah. Okay. So the thing is, but these chips are so hard to run. Like I didn't even run a 64 core. I ran a 24 core, and these are so hard. Like the 24 core was a pain. The 64 core is like that much worse, right? Because these things have a cold bug. Yeah, the cold behavior on just, well, Ryzen chips in general just have weird cold behavior, but then with the Threadrippers, they also pull stupid amounts of power. So not only do you have to fight with the weird cold behavior, you also have to deal with way more heat output. And with something like the 64 core at 1.55 volts, Cinebench R20, I have no idea how much power this would pull. I really have no idea. Like, a lot. Let's just leave it at that. Probably approaching 1,000 watts, if not exceeding it already, as the power consumption is mostly, like, is very heavily a function of the voltage you're at. The frequency, you know, that's a linear effect, but the voltage is exponential, or more like quadratic. So, yeah, if you're at 1.55 volts, like, even if this frequency is kind of low, the chip is going to be pulling a stupid amount of power. Now, obviously, if you're at higher frequencies, it'll pull even more. But, like, you're not really going to notice the difference that much. You're not going to notice the difference from, like, 100 megahertz of core clock as much as you're going to notice the difference of, like, 100 millivolts of voltage. So, yeah. Anyway, running this on the ASRock TRX 40 Tai Chi. Memory, like, single rank memory, 32 gigs. Running 3200, 14, 14, 14. Now, this is Cinebench R20, so the memory settings aren't super important, and running less aggressive memory settings and lower fabric clock on liquid nitrogen is actually one of the best ways best things you can do to try get Ryzen CPUs to run at lower temperatures. Looks like Miller had it down to minus 100 degrees Celsius, which seems a bit warm. Seems a bit warm. Like, some chips should definitely be, like, it should definitely be possible to get some of these chips to run straight up full pot. And then a lot of them will have cold bugs sort of approaching that temperature. And minus 100 is pretty warm, but at the same time, it's also, like, the point where you start running into the really weird issues. And at least when I was running the 3960X, it was like, yeah, it was pretty normal. Well, no, it was bad down to minus 100, but below that, it got so much worse in terms of behavior. So, yeah, you know, very, very, like, running this at all is just insanely difficult. So, yeah. I mean, let's take a look at what most other 3990Xs run, right? Like, yeah, the next closest scores are like... Also, it looks like a lot of people... Wait, do these care about memory settings? They might, because, like, the chip is running so high frequency. Or, oh, this is per CCX. Okay, so they're not actually running all core. That's probably part of it. Also, this validation screenshot is wrong. There's no CPU Z in it, so that's bad. So anyway, yeah, congratulations to Miller on managing to push that 3990X to third place in Cinebench R20, because, like, it's a really hard seat. That's like... That's going to be one of the hardest CPUs to work with that you could basically run on liquid nitrogen right now. Like, because it pulls a stupid amount of power, and then it's Ryzen on liquid nitrogen, which in and of itself is very challenging to begin with. So, yeah. Let's move on to the next score, which is QuickMew's HWbot X265 4K on 4 E7 8880 V3 CPUs. So this is the top score for the 72 core CPU category, or more like 72 core category. Yeah, this is server hardware, so here we go. Mew somehow got his hands on a server of some sort, and did this with it. Man, those were memory settings. What even is that? That's so that's half a terabyte of RAM, but running at DDR4 1600 CL10. So this is like straight up slower than DDR3. And then just 2.9 gigahertz on the CPU. So the thing is, QuickMew over here got first place in the 72 core category because nobody else has a 72 core like system. Like, what even is this? It's 4 18 core CPUs glued together, which is like a pretty weird, I guess, server configuration. Because you would assume that I would assume you'd probably just go for like the highest core count CPUs you can get in this kind of configuration. At the same time, this is Haswell E. This is just weird hardware. So yeah, an interesting score in the sense that like you don't see benchmarks run on HWbot on 72 core CPU configurations, well, ever, right? Like this is literally the only 72 core HWbot X265 run on HWbot currently. So congratulations to QuickMew on finding a 72 core server to run this with. I mean, congratulating him on being the only and first place is, you know, kind of weird in my opinion. But congrats to him on finding a very odd, like, I'm assuming this has to be a pretty odd server in order for it to be the only one to get submitted in this category. So anyway, let's move on to the hardware category scores. Starting off with DarkGregor's W Prime 1024M on the Core 2 Duo E8500 at almost 6.2 gigahertz on liquid nitrogen on a Rampage Extreme because, like, of all the, like, LGA 775, almost, like, for most of the CPUs, people are going to be running Rampage Extremes. So, of course, a Rampage Extreme here. From what I've heard, apparently, like, the best LGA 775 board, according to a lot of people. Or so I've heard. I've never done anything LGA 775 myself. Anyway, in terms of memory settings, that's some kind of weird Micron memory right there, because that 765, it's like, yep, that's Micron things. Well, yeah, that's Micron things. Like, as far as I know, if you see timings where if your cast latency is your highest timing, you've got Micron memory. At least most of the time, in my experience, because, like, DDR3 Micron chips do some very strange things. Anyway, then we have the Core 2 Duo at, almost 6.2 gigahertz running on almost 2 volts, which, it's not really that high. 2 cores, 2 threads, running for 6 minutes and 22 seconds. So a very, pretty long run, but, it's a dual core CPU running W Prime 1024M, which is a long multi-threaded workload. So that's not very surprising. And, yeah, I wish I could tell you more about this, but again, this is LGA 775, and as has happened on multiple HWbot score roundups before, I don't really know that much about LGA 775. I mean, we have a Rampage Extreme, which is kind of a given for a top score in LGA 775 benchmarking. And then, I mean, I will say the Micron memory is unique. Normally I expect to see LP to hypers, but for whatever reason, this is running on Micron, so... Or at least I assume that's Micron. I'm not 100% certain, but I'm pretty sure that's Micron. Also because those Corsair Dominators, I'm pretty sure I might have a similar kit, and it's in microns. Like, it uses micron memory. So, yeah. Anyway, congratulations to DarkGregor on taking the top score for the E8500. I'm assuming there's actually quite a lot of competition for this CPU. Yeah, there is, which is what you'd expect for a CPU this old. If a chip is really old, lots and lots of people have time to, try get a top score with it. So a lot of these old CPUs are like very competitive because of, well, they're old, and also they're really cheap. Like that's a big part of actually why they get really popular and very, very competitive. Anyway, let's move on to the next score, which is Matt 26 LFC's Cinebench R15 on the i5 4690K at just over 5.9 gigahertz. I was about to say just under 6, but nah, it's not close to 6. It's more than 70 megahertz away. That's not close. But it is, just over 5.9 gigahertz, running on the ASRock Z97 OC formula. Fun fact about this, is it this one? I think it is this one. Well, either way, for DDR3, ASRock had one or two, I'm not sure right now, motherboards that they had coming from the factory with conformal coating, which the cool thing about that is if you're going to run those boards on LN2, you basically don't have to do any like low level insulation. You just need like the shop towels to minimize water buildup. And the actual like waterproofing layer already comes on the motherboard from the factory. And I think the Z97 OC formula is one of the... I think the Z87 got it as well, and the Z97... Or maybe it started with the Z97? They stopped doing it because it made RMAs a nightmare. Like, you just couldn't repair motherboards that had came in with conformal coat. But, yeah, for DDR3, like, ASRock had conformally coated... OC formula boards, and I think this is one of them. So yeah, very, very cool motherboard, and from what I've heard, apparently basically the best, well, one of the best Z97 overclocking motherboards ever. Yeah, I do have one of these. I managed to get one of these super cheap on eBay because it was broken. It works now, but yeah, I've not run it very much. Like, I've checked that it runs, and that's basically it. Anyway, here's the actual score. So, 5.9 gigahertz on the 4690K, and then 2660, well, actually, that's 2680, 812, 8 on the memory, which, that's like, this is pretty normal DDR3, competitive, like, Haswell era DDR3 memory settings. So... yeah, though worth noting about Devil's Canyon, at least from what I've heard, because I don't bin CPUs, and I don't bin CPUs, but from what I've heard, Devil's Canyon generally isn't quite as good with LN2 as Haswell CPUs. And then I guess the 4690K isn't really that popular because like 5.9 gigahertz is actually kind of low. The thing is with the Devil's Canyon CPUs is they do have a cold bug, and this is also true of the Haswell CPUs. Like, you just can't run them super cold. But luckily, they're just like they are just quad cores, so they're not super difficult to handle in terms of temperature handling. Yeah, like, so fun platform to bench. And very, very solid score from Matt here for the 4690K in Cinebench R15. So congratulations to him on that. Actually, let's see how many people have run these on LN2. And yeah, I guess because Devil's Canyon just... The thing is, like, generally the CPUs that get for... Like, once hyperthreading started being a thing, the CPUs that would get all the attention for competitive overclocking are the hyperthreaded ones, because a hyperthreaded quad core still goes into the quad core CPU category, whereas a quad core CPU without hyperthreading, well, like a 4690K, outside of its own category, is going up against 4790Ks and 4770Ks. So it's not a super popular, like, at the time that it was relevant, it wasn't a super popular CPU for extreme, like for LN2 overclocking, because if you're going to be taking a chip on LN2, it may as well be a 4770K or a 4790K. But yeah, now that it's an older CPU, and also like it is worth noting that if you're looking for secondhand CPUs to pick up for like messing around with overclocking, i7s are extremely expensive because they're basically, well, they're consistently the best CPU for a given socket. So there's more motherboards than there are i7s. Like there's more motherboards compatible with i7 chips than there are i7s. So i7s are really, really like overpriced in the second-hand market, whereas i5s can actually be surprisingly cheap because, well, they're not as fast as the i7s. But yeah, which does, in my opinion, I would assume we should see more competition show up for the 4690K over time, because yeah, these CPUs are starting to get relatively cheap to get, and it should be a relatively common CPU as well, right? Because these were very popular chips when they were relevant for like regular users. It's just you wouldn't run them on LN2. But the performance they offered at the time that they were relevant was really, really good. So anyway, congratulations to Matt on pushing that 4690K to 5.9, to just over 5.9 gigahertz. And he also ran SuperPi 32M on it, which this is a single core benchmark, a very, very single core benchmark, heavily focused on memory performance, and also very memory stability intensive. So here we're running slightly lower memory clock, same memory timings, because, well, you're not really going to be running better memory settings than that. Well, okay, now like if you wanted to go faster than that on the memory, you basically need to take the memory sub-zero. So that's what's going on there. 6.2 gigahertz on the CPU now, just one core and one thread, because, well, it depends on the CPU, but if your best core is your first core, you're just going to run one core, right? Like if your best core is your second core, then there's an argument to be made for running two cores so that you can run SuperPi on the second core instead of the first core. But yeah, otherwise you're going to be running like one core, one thread, or at most two cores, two threads. If you run four cores, the extra heat output from the extra two cores is just too much. And also you need to be able to run the frequency across all of the cores at the same time, because 4690Ks didn't have per core multipliers at all. Like all of your cores were doing the same frequency if the benchmark was running. So yeah, you really don't want the extra cores to be there. Anyway, and SuperPi 32M is an old benchmark that loves Windows XP, and it also apparently runs faster if you use the olive green theme. And there's a bunch of other weird stuff that you need to do before running SuperPi 32 million in order to get a better score. But we're not going to get into that because I don't really bench SuperPi 32M very much. So, yeah. But a very, very difficult benchmark to get good scores in, because you need to really be like, because of all the weird OS things, like weird software things that you can do to make it speed up. And then also just like the fact that it's super memory intensive. So you can really like, a lot of it is about maxing out your memory settings. And then of course, just the frequency you run it at. Like it is a single threaded benchmark. You want to clock the CPU as high as possible as well. So yeah, a very, very difficult benchmark to get good scores in. And, Matt took first place for the 4690K here with his setup. So congratulations to him on the first place in SuperPi 32M with the 4690K as well. Anyway, let's move on to the next score, which is Pirat's 3D Mark Firestrike top score with the GTX 770. On liquid nitrogen, running 1750 core, 2000 on the 2000 megahertz on the memory. And is this thing okay? This looks like a direct CU. Oh, this is going to be a G. So yeah, so this looks like a direct CU2 card, I think. Does it say? Yeah. Okay, so it's a GTX 970 direct CU2. I mean, GTX 770 direct CU2. Yeah, core absolutely flying. Like Kepler card, I'm not sure actually. I wonder how much voltage they're giving it. Like, it is currently the fastest 770 on HWbot, but the thing is, Firestrike also has a CPU component. Well, not many people ran these on LN2, and the only card to ever run faster was actually running lower memory. So, yeah, I guess, like, at least compared to all the other 770s, absolutely flying, because there's not... So, yeah, absolutely flying with the 1750 memory, core clock, and then 2000 on the memory. Yeah, so picture from the session. There's the card with the LN2 pot and the insulation. CPU on chilled water cooling. What CPU is it? 5950X. So absolutely massive physics score thanks to the 5950X. Yeah, not really much else to talk about here, I don't think. I mean, well, I will say that Kepler cards are really, really fun to overclock. They're like the last generation of NVIDIA GPUs that had proper voltage scaling. Everything after that is horrible. Especially like 900 series and 10 series, awful. Like, does not scale with voltage until it's at like minus 20 degrees. I don't know about 20. I think actually 20 series is basically the same, and 30 series, I don't know at all what it's like. But yeah, so congratulations to congratulations to Pirat on the 3D Mark Firestrike top score with the GTX 770, and let's move on to the next score, which is ShaggySVK's 3D Mark Vantage with the GTX 970, 3D Mark Vantage performance with the GTX 970. And this GTX 970 is a bit special because it doesn't have its stock V-Core VRM anymore, probably because it blew, like the original VRM probably blew up because this is one of those NVIDIA cards from the era of garbage build quality on... Actually, I'd argue reference 3080 PCBs are pretty trash too, but not as bad as what NVIDIA used to like be okay with for their GPUs. Especially the lower end cards for everything pre-10. Like, actually no, even the 10 series. Like, most of the cards are garbage except for the 1080 Ti in terms of build quality. Yeah, so basically what's going on with that board hanging off of the side of the card there is that's an e-power, so that's completely replacing the stock VRM of the card, because I suspect the stock VRM blew up at one point, which is a very common thing for older NVIDIA cards, especially if they don't have proper custom PCBs, because the build quality of them is just miserable. Yeah, and I believe this is actually from the, I think Pirat and ShaggySVK actually did like a joint bench session. So if you're looking at this 5950X cooling setup here and going like, wait a minute, isn't that the same thing? It's like, yeah, that is the same thing. The way the rules work on HWbot is if you're benching a 3D benchmark like 3D Mark Vantage or Firestrike, sharing the CPU, like multiple people using the same CPU is fine. You just can't share GPUs. Like, you can't have two people bench the same GPU because that's like you'd end up with people just passing one card around between each other and everybody having a score, like, a top 10 score that's like 2 points apart, which is like, no, don't do that. But the CPU is like, this is a GPU benchmark, debatably, with that CPU score over there. And so the CPU is fine, but you can't share the GPU. Anyway, GTX, like this thing is flying, like 1900 megahertz on the core, over 2 gigahertz on the memory. Yeah, running 4600, 14, 13, 13 on the memory for the CPU, and 5.1 gigahertz all like on 16 cores with 16 threads. The thing is, 3D Mark Vantage being an old benchmark doesn't work with more than 16 threads, and so if you give it if you have a fully enabled 5950X running 16 cores, 32 threads, it'll actually score worse, significantly worse than if you disable SMT. So disabling SMT for Vantage is like one of the biggest things you can do to improve your CPU score if you have a CPU that has more than 16 threads. If you have less than 16 threads, then you don't need to worry about this. Or if you have 16 threads, you also don't need to worry about this. Anyway, so yeah, this is just a really cool score. It's, you know, cool to see the card on an e-power. And also doing so well on the core clock, because the thing about a lot of the e-power mods is like you can never get the, like, e-powers don't really compete very well with like full-blown custom PCBs, because you just can't get the connection quality to rival that of a VRM that's actually just built onto the same PCB as the stock as the core. But yeah, so like pushing 1900 core on a e-powered GTX 970, like that's really impressive. Anyway, let's move on. So congratulations to ShaggySVK on the first place with the GTX 970, and let's move on to the next score, which is Lumi's PieFast with the 3770K. Lumi has a YouTube channel. I highly recommend you check it out. He does a bunch of extreme overclocking content. And so I don't know much of anything about PieFast. I mean, it is an old benchmark. It runs best on Windows XP. And that's about all I know about it. I also know that apparently it regularly runs at frequencies higher than what you can save in the screenshot, because it's like super low load. But I've never run it myself, so I don't know if that's true. But that apparently is like a real issue with it, where it's like you can run PieFast at like 7.1 gigahertz, and then you open up CPU-Z, and the act of opening CPU-Z at 7.1 gigahertz crashes the system. So like the benchmark is less hard to run than the actual process of saving the score. Which yeah, makes this a bit of a weird benchmark because of that. So Lumi's running, like, he's also running the memory on LN2 here, and some really impressive memory settings, right? Like we're looking at the 2700 710.6 on the memory, which is possible thanks to the LN2 on it. And then the CPU doing almost 7.1 gigahertz, like just under 7.1 gigahertz. And PieFast is another like single-threaded benchmark, so just one core, one thread. And if you want more details on the score, I think I think Lumi actually straight up linked some video down there. So you should really go check out his YouTube channel, because he does a ton of LN2 overclocking content, covering a very large variety of hardware. You know, some LGA 775, 3770K. He's 2080 Ti's, 3090s. Like he does the everything, like from, you know, very modern to what I would consider very old with LGA 775. So yeah, congrats to Lumi on, you know, managing the second place on the 3770K in PieFast, and let's move on to the next score, which is ChipC's 3D Marco 3 with the R9 270X at 1335 on the core and 1680 on the memory. I love 270Xs. Actually, all of the like first gen GCN cards, so much fun to overclock, and the smaller the core, well, okay, that's not entirely true. 7770s are weird, but Pitcairn and Tahiti cores, awesome. And Pitcairn's even better than Tahiti in my opinion, because Pitcairn clocks way higher thanks to being smaller. So yeah, these cards are super fun to overclock. And yeah, anyway, ChipC 3D Marco 3, old benchmark, very CPU bottleneck. Like, again, one of those benchmarks where it's like, you know, like it's running at thousands of frames per second with this 270X over here. So it ends up hitting a pretty heavy single-threaded CPU bottleneck. And so ChipC's running the 11900K with just 6 cores and 6 threads at 5.8 gigahertz on a single stage phase change. And the memory running, again, optimized for minimum memory latency. So 3760, yeah, that's like almost 3760, 13, 13, 13, 24 timings. And then the card doing 1335 on the core, 1680 on the memory, which is, without significant modification, that's about as high as you're going to push these if you're going to be on, well, yeah, water cooling or air cooling. The thing is, 270Xs don't put out a lot of heat. So what you end up usually limited by is not so much like, because the core is relatively small, so they really don't get that hot. So what you usually end up limited by is like just the voltage slider in the software. It doesn't go high enough to really yeah, like basically you're gonna hit the limits of the voltage control before you like on air cooling and water cooling. There's other cards out there where it's like you're gonna hit the temperature limits, but with 270X is like you need hard mods if you really want to push the voltage super high, or you might be able to get some software to get around the limits, but I've not had much luck with. Yeah, I don't remember having much luck with that on the 270X, because I think I ran, like, I have a 270X and I maxed out at similar clocks for basically the reason of I ran out of voltage slider in the software. So in the future I plan to fix that, but for now it's like my scores are voltage limited, not cooling limited. Anyway, the interesting thing about 3D Mark 03 is that even though it is very CPU bottlenecked, as you can see from the 5.8 gigahertz 11900K, it does still scale with GPU clocks. It's not one of those, like, there's some benchmarks where you can literally leave the GPU stock and it's not going to affect the score. But 3D Mark 03, overclocking the GPU still makes a pretty significant difference to the score. So it's not just about having a really fast CPU, and that makes it a pretty interesting benchmark, even though it's not a benchmark I really run very often, because it's also one of the sort of weirder ones in terms of software optimizations. So yeah. Anyway, congratulations to ChipC on taking first place with the first place in 3D Mark 03 for the R9 270X, and let's move on to the next score, which is man, I'm friends with this guy, and I'm gonna butcher his name. I think it's Kachisipa pooches. I butchered that. Anyway, 3D Mark TimeSpy third place on the RTX 2070. 2025 megahertz on the core, 2075 megahertz on the memory, and a very clean but unique cooling system. Right? That is a CPU cooler strapped to the GPU core. That looks a lot. It looks like a Founders Edition PCB. So I'm like, yeah, the stock NVIDIA heatsink. It's better than a blower, but it doesn't beat a CPU heatsink. And he does have proper mounting hardware on that for that. Like, you can see, like, it's not just zip tied on. So, you know, that man's got standards here with attaching that heatsink. Because if this was me, I would have just zip tied the thing on. So yeah, I wonder if that's the permanent configuration of that card. I kind of doubt it, because it's really impractical. Anyway, running with a 10900K at 5.3 gigahertz. 10 cores, 20 threads on the EVGA Z490 Dark. And yeah, so quite the intense air cooling setup for the GPU, and then water cooling on the CPU. 360 millimeter radiator. So yeah, solid result. Third place in the TimeSpy ranking for the RTX 2070. So congratulations to, I give up on his name. I'm not going to try again. I butchered it the first time. We don't need to do it twice. But yeah, congratulations to him on the third place with the RTX 2070 in 3D Mark TimeSpy. And let's move on to the last score of this week's roundup, which is U9600's 3D Mark TimeSpy score with the 6700 XT, doing almost 2.9 gigahertz on the core. Actually, let's check what 3D Mark is reporting, because this is always... 3D Mark is reporting 2840. Don't you love how it's impossible to tell what frequency you're running your AMD GPU at? So GPU-Z is reporting 2840, 2801. Yeah, frequencies all over the place. Anyway, 1.2 volts on the core, 233 GPU chip, 233 watts of max GPU chip power draw. Ryzen 7 5800X doing 4.9 gigahertz, so really pushing that CPU quite hard there. It is on Arctic. I can't tell what size that is, but yeah, Arctic cooling AIO, and then an XFX 6700 XT just on air cooling. So yeah, beating the previous top score for the 6700 XT by about 100 points. So still a solid result. I wonder if, well, I believe the 6700 XT now has a 3 gigahertz core clock limit. I wonder if we'll see anybody hit it, because it should be possible. Like, if the 6700 XT scales with voltage like a 6900 XT does, then it should just be a matter of hooking up an Elmore EVC2, giving it 50 millivolts more, and you'll slam right into the 3 gigahertz limit. Actually, you could probably give it a lot more voltage than that, because the chip doesn't pull that much power, so temperatures are, yeah, like the temperatures are great, right? 47 degrees core, 70 degrees hotspot, like, needs more voltage. Really, like, all of the 6000 series needs better voltage control, because they do scale, like, it doesn't scale a lot. Like, it doesn't scale enough to justify the power consumption increase, but it does scale enough to justify running it at higher voltage for benchmarks. So, yeah, and then in terms of memory settings, dual rank memory running 1414, 1428. So yeah, just a very solid, 6700 XT overclock here. I wonder if he's running modded power play tables. One of the, I don't know what the stock power limits are for 6700 XTs, so I have no idea. But yeah, solid result from U9600 here for the 6700 XT, and so congratulations to him for taking first place in the 6700 XT rankings. And that is it for this week's roundup. So, yeah, thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below if you'd like to support what I do here with actually hardcore overclocking. I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, the usual YouTuber merch. Both the Patreon and Teespring help out immensely with running the channel, so it would be much appreciated if you check them out. And that is it for the video, so thank you for watching, and goodbye.